Now we're going to go through the list of the steps for graphing these rational functions. If there's nothing of something, we're going to write that, and you'll see it in just a minute. So first thing we're going to do is always look for holes. So the holes, if you look at the paper, oops, put in a different one. So holes where there's a common factor of the top and the bottom. So we're going to look at that first. Wrong window. So if there's a common factor on the top of the bottom, there's none. Or if there's not a common factor. Same thing for number 2. There's no hole. And I would do this first. Number 3, okay, I don't know if there's a hole or not because we have to factor them. So when we factor number 3, the top factors into x plus 3 times x plus 4. The bottom, I can take out a negative 4 first. And get that, which is x. I'm going to write a little bit bigger and in a darker color, I realized. The bottom, I can take out a negative 4. And I get that. And then I can see that there's a common factor. So for number 1, there's a hole at x equals negative 3. And we're going to see in a little bit how we're going to graph that. But just know we don't have the math to find where exactly that y value is. You don't have the math to find it out. We can figure it out as mathematicians, but in Algebra 2, we just say that there's a hole at x equals negative 3, wherever that is. So along this line here, and if you want to just mark it lightly, there's going to be a hole there somewhere. And again, we're going to see exactly where to graph that. Number 4, we do have to factor the top to see if there's a common factor. So that's what we get when we factor. For number 1, there's no hole. So I would probably add onto that sheet that we're going to use factored form for this. Because sometimes it's easier to use the factored form, sometimes it's easier to use the non-factored form. So that's step 1. Now we're going to find the vertical asymptote. So I wouldn't go through and do that for each of these problems like I did for the holes, but I just wanted to make sure that we knew that there was a hole in number 3. Because we're going to forget about that once we graph it. So step 2 is we're going to find the vertical asymptote. The vertical asymptote, if you look at your paper, remember it's the domain restriction. So the domain restriction is all the x values that x can't be. So what I'm going to do is figure out when is x equal, or the bottom equal to 0. Well, the bottom is equal to 0 when x is negative 2. So I set the denominator equal to 0 and I solve for x. So that means that there's a vertical asymptote at x equals negative 2. And I would graph it as you find it personally. So this is not part of the graph, but it's just marking. The graph isn't going to go through it or touch it. The third step I'm going to do is find the horizontal asymptote, or the slant asymptote. For the horizontal or the slant asymptote, we are going to use the non-factored form. So I do want to note on that other paper, for the holes, we use the factored form. For the vertical asymptote, we use the factored form. For the horizontal, we use the unfactored form because we need the highest degree of the top and the highest degree of the bottom. So the degree of the top is 0. The degree of the bottom, I don't know why that keeps doing that. The degree of the bottom is 1. So the degree of the top, which is n, is less than the degree of the bottom, which is m. It's so much easier to say that n is less than m than saying the degree of the top is less than the degree of the bottom. So we look back at that paper and we look at the middle case. So if the degree of the top is less than the degree of the bottom, the horizontal asymptote is at y is equal to 0. So it's a horizontal asymptote, not a slant asymptote. So that's at y is equal to 0, which is here. Oops, wrong way. So that's the horizontal asymptote and the vertical asymptote, and I did label them on the graph too. I personally would use different colors. Even graphing these for so long, I would use different colors. I would label everything. Because you might go back and think like, wait, what's this part? Or I messed up. Let me see where I messed up. And it's really hard to go back and check it. All right, step 4. So there's no slant asymptote, but there's a horizontal asymptote. We can't have both. Step 4 on the paper is the x-intercept or x-intercepts. Remember, when we're finding the x-intercept, what we're really doing is making y is equal to 0. To find the x-intercept, y is always 0. But what's going to happen every single time is when I clear the fraction, we're always going to have 0 equals the numerator. So on that sheet, it says, for the x-intercept, set the top equal to 0 and solve for x. The reason why we can do that is because really we're substituting y is equal to 0. So what we're really doing is substituting y is equal to 0, and the denominator is going to go away when we clear the fraction because you're multiplying by 0. So since 0 does not equal to 3, there is no x-intercepts. And for step 5, we're going to find the y-intercept. I'll put it down here. And yes, these do take a long time. But it'll get a little bit quicker. So the y-intercept, we substitute x is equal to 0 like it says on the paper. And then we simplify the problem. So we substitute x is equal to 0, and then we simplify the problem. If we substitute x is 0, I get 3 over 0 plus 2, which is 3/2, which we can write as 1.5. When we're graphing, I would write it as a decimal. So 0, 1.5 is the y-intercept. So now I know I'm going to write something in highlighter, and I don't want you to write this. So now I know, since there is a y-intercept here, there's 4 quadrants. We're either going to have a graph here and here, or here and here. Because there's that y-intercept here, I know that the graph has to be there and there, because that y-intercept is already in the first quadrant, even though the vertical asymptote is at -3 and -2 instead of 0. So I know that it's going to be there. So what I'm going to do is, for the 6th step, we're going to find additional points to graph. I'm going to choose values of x to find values of y. So I'm choosing values of x to find values of y. Next part, I want to try to do it much neater. So to choose values of x to find values of y, I'm going to make a t-chart. I already have the point 0, 1.5 from here. That's my y-intercept. So I need to find more points over in that first quadrant. So maybe I'll choose x is -1, because that's somewhere in here. I'm not going to choose x is -2 because that's my vertical asymptote. So if I choose x is -1, substitute it into the original equation, you get 3 over -1 plus 2, which is 3 over 1, which is just 3. So it's -1, 3. Again, I can't choose -2 because it's the vertical asymptote. So now I have -1 chosen, I have 0 chosen for x, and now I'm going to choose 0 for x and see what I get out for y. I'm sorry, 1 for x. If I substitute 1 into the original equation, I get 3 over 3, which is 1. So it's 1, 1. I can substitute in 2. I get 3 over 4, which is 0.75. So I can go 2 out and then like 0.75 here. I can go 3 out, put 3 in there, 3 over 5. I don't know what that is off the top of my head as a decimal. 0.6, I don't know. I'm not even going to pretend like I know. I think it's 0.6. But what's going to happen is it's going to get closer and closer and closer to the x-axis, but it's not going to actually touch 0. So I can keep going down to 4, 5, 6, 7. No matter how far up I go, it's not going to be 0 because of the horizontal asymptote. So there's a lot of thought that goes into these graphs. There's nothing really challenging about them, except that you have to think. All right, so, and I'm going to show you an easy way next time. Well, you know what? I'll show you now. So we should do that. We should do this and this. But I am totally okay with you. If you get that first quadrant, then you just reflect it here as best as you can. Just try to make it look like it's going near the horizontal asymptote and the vertical asymptote. It doesn't have to be perfect, but just so that I know that you know that there's a graph here and that is a pain in the hiney to go through all that work. So we can do that. I'm going to do the problems that way when I do them for the classwork. Or you can pick up your handy dandy Inspire. And I know you know how to substitute numbers into an expression. I know you know how to get out numbers. So if you find, let's redo this part over again. I'm going to ignore that we did step 6. I find that 0, 1/2 is the y-intercept. I know that the graph is there. I can pick up my Inspire and graph this rational function. You do have to show all of that work. This part, step 6, it's not necessary if you use the Inspire. So you can graph it in the Inspire and confirm that your graph is in that top right corner, or that first quadrant, if you want to think of it that way. It's not really the first quadrant, I guess. And then you'll see in your Inspire that it's here. It would be silly not to use your Inspire. I know some teachers are like, oh, no calculator for this. I don't care. If that's what you have to do in order to get the problem right, then that's what you do, because you still have to show all of this work on the left-hand side. You can't just, and you can't get the vertical asymptote from the Inspire. You can't get the horizontal asymptote from the Inspire. You can't, you can get the y-intercept and x-intercepts from the Inspire, but you can't get what's going on with the graph with your Inspire. The Inspire is just a tool to aid you, to help you. I was just trying to think of I forget even the word. metaphor. I don't know. Something that's similar to it. Like, it would be like, all right, make this cake, but you can't use this electric beater. You're going to have to use a whisk. Well, why? I'm just going to have to use an electric beater. Use the tools available, especially now in this day and age with this new way of learning. We're going to totally revamp the way that we learn, the way that we teach. We're not going to just make everybody memorize everything. Should you be able to know what a vertical asymptote is and a horizontal asymptote is if you're in honors algebra 2? Absolutely. But you don't have to. Sorry, my mom's calling me. You don't have to memorize everything. You'd be like, oh, I think I know what it is, but I'm going to use this tool to help me. I do it sometimes too. I do things in math that I haven't done for a long time. At one time, I knew how many planets there were in the solar system. 7, 8, 9, 10. I don't know. Is Pluto one? I don't know, but I can look it up. So knowing what you don't know and being able to use your resources wisely is very important to me for you to know. All right, so big spiel over. Next video is going to be number 2. These do take a while in the beginning. After a while, you'll find some shortcuts.